Hi class, this is Mr. Eder, and today I want to talk to you about stoichiometry and how to solve these problems. I will go through how to set up the problems first, and then we'll look at 3 examples of stoichiometry problems. First off, when we're setting up the problems, it's important to know that we are trying to solve or usually figure out how to go from a certain amount of reactants and figure out how much product that would make, or if we wanted to make a specific amount of product, how much of the reactants we would need. So in order to do that, we first need to start with a balanced equation. This is really important because the balanced equation is our recipe, or it tells us how much and in what ratios the reactants and products will produce. Also, when we set up these problems, we need to talk about measurable quantities. Oftentimes a problem will show you or will give you these measurable quantities. You will then need to think through conversion factors to go from measurable quantities to moles, or depending on the problem, going from moles to measurable quantities. And it is moles that are very important here. But first, let's talk about measurable quantities. These could be mass, which is grams, or volume, which is milliliters and liters, particles, such as molecules or atoms or formula units. Then we need to figure out conversion factors to get from that measurable quantity to or from moles. We could use molar mass, we could use density, we could use molarity or gas law equations. Those last two we haven't talked about yet, but you will see as we go throughout the semester that we can use those to solve stoichiometry problems. And lastly, moles, as I said, is really important because you will always need to know the number of moles in order to solve a problem, because it's a mole ratio between the reactants and products that allow us to determine how much we can make or how much of something we would need. So remember that measurable quantities, conversion factors, and moles is very important. How you set up these problems is really important, and so I suggest that you stay organized by keeping the measurable quantities on top and the moles on bottom, and the conversion factor used in between. So in this first problem, I want to show you how to use a mole ratio. And it says how many moles of water can be produced from the reaction of 5 moles of oxygen and excess hydrogen. As I've said, what's really important is you need to start with a balanced equation. From this balanced equation, we can then read the problem and identify what we have and fill it in the correct spot. It says that we have 5 moles of oxygen, so I'm going to go ahead and put 5 moles underneath oxygen. The problem then asks us for how many moles of water we can produce. So we need to know the mole ratio to go from moles of oxygen to moles of water. If you look at the balanced equation, you can see the coefficient of 2 in front of water and a coefficient of 1 in front of oxygen. So we have a 1 to 2 ratio, which means that twice as much water is produced as oxygen is required. So we would produce 10 moles of water. In the second problem, we have theoretical yield, which means how much should we produce. So what is the theoretical yield, or how much magnesium chloride should we produce when 6.02 grams of magnesium reacts with excess hydrochloric acid? So again, we have to start with a balanced equation, and then we can fill in from the problem what we need in order to figure out how many grams of magnesium chloride we could make. The problem says we have 6.02 grams of magnesium. That is a measurable quantity. So how do we get from grams to moles? So that's using the molar mass of magnesium, which is 24.31 grams per mole. So we can then solve for the moles of magnesium that we started with. And then just like the mole ratio, we can use the mole ratio. In this case, the coefficient in front of magnesium is 1, and the coefficient in front of magnesium chloride is also 1. So a 1-to-1 ratio, we would produce 0.248 moles of magnesium chloride. So the problem says what's the theoretical yield? And so we need to solve for the amount of grams of magnesium chloride produced. So how do we convert 0.248 moles of magnesium chloride to grams of magnesium chloride? Again, we would use the molar mass, which is 95.21 grams per mole. And using those two values, we can solve for 23.6 grams of magnesium chloride should be produced in this reaction. Our last problem is a little bit different problem where it's mixing a couple different conversion factors. And it says how many molecules of carbon dioxide are produced from the complete combustion of 10 grams of propane. Again, we start with a balanced equation. Then we look to the problem to fill in whether we have measurable quantities or moles, and then we can think through the conversion factors. So the problem says we have 10 grams of propane. So I fill in 10 grams as a measurable quantity above propane. I need to convert to moles, so how do I go from grams to moles? Well, again, I use the molar mass, which is 44.11 grams per mole for propane, or C3H8. When I convert 10 grams to moles, I get 0.227 moles. And then, like always, I need to use the mole ratio to figure out how much carbon dioxide we would produce. So if you see the coefficient in front of propane is 1, and the coefficient in front of carbon dioxide is 3, we have a mole ratio of 1 to 3, meaning there's 3 times as much carbon dioxide produced as propane. And so when we multiply by 3 to take into account that ratio, 0.681 moles of carbon dioxide would be produced. But now the problem asks for how many molecules of carbon dioxide are produced. Well, how do we convert from moles to molecules? That conversion factor is 6.02 times 10 to the 23rd molecules per mole. When we convert moles into molecules with that conversion factor, we end up with our answer of 4.10 times 10 to the 23rd molecules. So there you have 3 problems. Remember that it's really important to stay organized, and so you need to come up with some way to show your work and some way to organize your process so that you don't get confused. I would recommend putting your measurable quantities, grams or molecules or milliliters, above the reaction, put moles below the reaction, and again, how do you convert from that measurable quantity to moles would be the conversion factor you use, and put that in between. Thank you very much.